Where is the acid? My staff hears me say this more than they probably care to remember. But where is the acid is really the central question when we create a new dish. When seasoning food, everyone talks about salt. I believe acid is just as important, maybe more important than salt. When I grew up in Switzerland, I was always drawn to acidic foods. I love tomatoes, I love citrus fruits, I love pickles. My mom's cooking, sauerkraut, roasted chicken with lemon and rosemary. She made a braised rabbit with olives, orange, and pickled onions. I never knew exactly why I was drawn to these dishes so much, why they were my favorite. But looking back, it makes sense because there was presence of acid, which gave it balance and it highlighted the food. And it just makes food better. Acid just makes food better. At 11 Madison, we serve tasting menus, 14, 15, 16 courses. It's important that all these dishes have acid. We use acid from so many different sources, but it keeps the guest excited, it keeps the meal lighter, and it makes the guest want more.
So what is an acid? An acid, by definition, is a molecule that releases a hydrogen ion. And so here is an image of citric acid releasing a hydrogen ion. And this measure of how strong an acid is a measure of how easily an acid gives up that hydrogen ion. And so, for example, citric acid gives up the hydrogen ion not as easily as, say, sulfuric acid does, which we use in car batteries. The hydrogen ion is taken up by the water, and it's giving us, instead of an H2O, it's giving us an H3O+. And this is usually referred to as a hydronium ion. So how acidic something is then is a measure of how easily hydrogen ions are given off, and we usually also refer to hydrogen ions as protons. And the more hydrogen ions and indirectly how many hydronium ions there are around is what gives us a measure of how acidic something is. So it turns out that the number of hydrogen ions in water naturally is 10 to the power of -7 moles per liter. Or in a liter of water, in fact, there is 55 moles of molecules per liter. And so 10 to the -7 then is actually a very, very tiny amount, but nevertheless, this is how many hydrogen ions there are in water. Water is thought of being neutral, and acids are molecules that easily give up hydrogen ions, and so they're acidic. And so then at the other end of the spectrum, we have molecules that are very, very reluctant to give up hydrogen ions, even more so than water. And those we think of as bases, or basic molecules. And there is a mathematical formula for this, which is pH equals minus the logarithm of how many moles per liter of hydrogen ions we have. And so if we do this for water, where we know that the number of hydrogen ions is 10 to the -7, and we plug this into this formula, we say minus the logarithm of 10 to the -7, and for those of you who are comfortable with logarithms, you immediately see that the answer to this is 7, and if you're not, you can plug this into your calculator and actually see that the number for this is 7, and so the pH of water is 7. And this is something that a lot of us are very familiar with, and if not, this is a good reminder.
We're using a pH meter at the restaurant, and we're using it as a measure to give us more consistency, more accuracy. We're using it in a way we use a scale, or in a way we measure temperature. So we took our still water, and this is the water we serve with our meal, and we measured it at 7.5. 7 is neutral, so it's very close to neutral. We also looked at the manufactured foods. Coca-Cola is more acidic than red wine vinegar. Just imagine that. Isn't that crazy? You eat that with your meal. It's more acidic than red wine vinegar. That's unbelievable. And when you drink Coca-Cola, you never think of it as being acidic. And that is why and that's because there's so much sugar to balance all that acid and makes it a beverage that everyone loves.